Hello, this is part 2 of my line segment intersection tutorial. Last time I showed you how to draw two lines on a canvas and move their endpoints around. Today I'm going to show you how to detect if they intersect or not. Before we start coding, I want to clarify the difference between a line and a line segment. The things you see on the screen are actually line segments because they have finite length. A line, on the other hand, continues forever in both directions. So a line segment is part of a line, bounded by two endpoints. With that in mind, let's go to our line class and create a new function called intersects. That takes another line as parameter and returns a boolean. To make things easier later on, I'm gonna assign the coordinates of both lines to new variables. Val x1 equals start.x, val y1 equals start.y, val x2 equals end.x, val y2 equals end.y, and the same for the other line, x3, y3, and x4, y4, and insert other here. I'm going to use the vector equation for lines, which goes something like this. If you have a line defined by 2 points, P1 and P2, you can calculate any point on the line by taking P1 and add a variable called u multiplied by the vector from point 1 to point 2, which is P2 minus P1. If you set u to 0, P is P1 because this part is 0. If you set u to 1, P is P1 plus P2 minus P1, which is P2. If you set u to 0.5, P is exactly the midpoint between P1 and P2. So if u is between 0 and 1, you get a point that's on the line segment defined by P1 and P2. But if u is less than 0 or greater than 1, you get a point that's on the line, but not on the line segment. Now let's take this equation and split it up into its x and y components. First, for this line, x equals x1 plus ut, the t stands for this, times x2 minus x1, and the y component equals y1 plus ut times y2 minus y1. Now copy that for the other line. Change 1 2, 3, T2O for other, 2 to 4, and 1 to 3. The intersection has the same coordinates on this line as on the other line, so we can set them equal. So first, this equals this, x1 plus ut times x2 minus x1 equals x3 plus uo times x4 minus x3, and the same for the y coordinate. Now we have a system of two linear equations with two unknowns, ut and uo. I'm going to use Cramer's rule to solve this system. First, we have to rearrange the equations so that the unknowns are on the same side. So ut times x2 minus x1, then bring that to the other side, minus uo times x4 minus x3 equals x3 minus x1 from this side. Copy that for y. But I want this to be plus, so I have to swap these in here, and the same for the y coordinate. Now we can substitute the constants to make things a little bit easier. So for x2 minus x1, I put in ax plus uo times, for this I choose px, and for this cx, and of course the same for the y coordinate. Now we can do the same outside of the comment. Val ax equals x2 minus x1, val ay equals y2 minus y1, val bx equals x3 minus x4, val by equals y3 minus y4, val cx equals x3 minus x1, and val cy equals y3 minus y1. Now we're ready to use Cramer's rule. But you could also use other methods to solve this system of linear equations if you don't want to remember Cramer's rule. First, let's calculate ut. Ut equals the determinant of Cx, Bx, Cy, By divided by the determinant of Ax, Bx, Ay, By. And UO equals the determinant of Ax, Cx, Ay, Cy divided by the determinant of Ax, Bx, Ay, By. The denominator is the same for both variables. You just take the constants on the left hand side of the equations. So Ax, Ay, Bx, By. For the numerator, you take the denominator and replace one column with the right hand side of the equation. For ut, you replace Ax, Ay with Cx, Ey, and for UO, you replace Bx, By with Cx, Cy. Now we can calculate the determinants. The denominator equals Ax times By minus Bx times Ay. The numerator equals Cx times By minus Bx times Cy, and the other numerator equals Ax times Cy minus Cx times Ay. We have to consider some special cases. If the denominator is 0, there's no solution because we would divide by 0. That's the case if the lines are parallel and there's indeed no single intersection point. So if denominator equals 0, the lines are parallel and we can return false. But if they are parallel, they can also be collinear, which means on the same line. That's the case if the numerator and the other numerator are 0 as well. So if numerator equals 0 and other numerator equals 0. But it's actually enough if only one of them is 0, because if the denominator is 0 and one of them is 0, the other one is 0 as well. If they are collinear, they can either be separated or overlapping. I normally don't consider it an intersection if they are overlapping, but I want to show you how to handle that case if you think differently. The line segments are overlapping if one of the endpoints of one line is between the endpoints of the other line. But if they are collinear, it's enough to check only the x-coordinate or only the y-coordinate. So we can return true if x1 is between x3 and x4, or if x2 is between x3 and x4, or x3 is between x1 and x2, or x4 is between x1 and x2. Unfortunately, there is no is-between member function of float, so we have to create one ourselves. Go to extensions and write fun float is between num1 of type float and num2 of type float equals the minimum of num1 and num2 import min from Kotlin math is less than or equal this, and this is less than or equal the maximum of num1 and num2. Import max from Kotlin math. Now we can go back to our line class. If the denominator is not 0, we can calculate ut and uo. Val ut equals numerator divided by denominator, and val uo equals other numerator divided by denominator. If ut and uo are between 0 and 1, the intersection is on both line segments and we can return true. If only one of them is between 0 and 1, the intersection is on that line segment, but not on the other one. And if none of them is between 0 and 1, the intersection is only on the lines, but not on the line segments. So return ut in 0.0 to 1.0 and uo in 0.0 to 1.0. Now we can finally test our new intersects function inside custom view. For this, let's create a new variable called collision and set it to line 1 intersects line 2. In the onDraw function, we can change the background color to red if there is a collision. And we have to update collision every time we move one of the endpoints inside onTouchEvent when action is action move. After we set the endpoint's new position, we can say collision equals line 1 intersects line 2 and run the app. The background is red because there is a collision. That's good. and it turns green if there's no collision. Now we should probably test one of the special cases by making the lines collinear and overlapping. The problem is, I did it. It's usually very hard to do that by hand because they have to be perfectly on top of each other. So you can test this by setting the coordinates in the code. Let's change line 2. Set the starting point to 400, 400 and the end point to 600, 600 and run the app again. The background is red because they are overlapping. That's all for this tutorial. Goodbye.